Hi again. I see that Graziano is here already. Hi, Graziano.
Hi, Greg. Before starting, just confirm that you hear me well.
Yeah, we hear you perfectly, Graziano.
Okay, perfect.
We hear you perfectly. And yeah, as I said before, this is the final presentation of the day. And this is going to be about the pilot action that happened in Italy with our cooperation. So Italian-Polish cooperation. And Graziano will also have a couple of slides about their other pilot actions. So take it away, Graziano.
Okay, is it full screen?
Yeah.
Okay. Okay, good afternoon, everybody. My name is Graziano Elegir, and I work at Innovab, which is an industrially oriented multi-sector research center located in Milano. We have 4 different technical divisions in our research center, and the one that participated to this project is the paper division. Paper division that actually carried out also some horizontal activity, not only specifically related only to paper, and I'm referring particularly to the laboratory of biodegradability and compostability, as well as the group that deals with the sustainability of different materials. Okay, the topic of my presentation today, as Greg mentioned it, this presentation will be done by 2 hands because we mostly cooperated also with the Institute of Biopolymer and Chemical Fibers of Warsaw. As Greg mentioned, it will be mostly the presentation regarding one of our case study. But before entering into the detail of the case study done with one of the company, let me summarize briefly what we have done also with the other companies. In Italy, we carried out 3 pilot actions. I would say at increasing complexity of the topics that we deal with. The first one was with the one small and medium enterprise. We just supported them, informing basically regarding what are the suitable certification scheme for recyclability and compostability of their products. Their products were mostly paper-based sacks, and they were developing also some biocomposite with some bioplastic. The second pilot action was about the recyclability evaluation of some innovative compostable packaging. And this was done because this company wanted to evaluate whether or not this compostable packaging was also suitable for recyclability. This is a kind of tricky topic because, as I will discuss better in my presentation tomorrow, not always those products that are developed for compostability are also very much suitable for recyclability. The third one is the one that we are discussing more in detail today, and it regards a preliminary study of life cycle analysis of a new paper-based tray for fresh meat application. So, what we did in the beginning. In the beginning, we approached this company. This company is LIC Packaging SPA, which is a large Italian paper converter. Their main production is actually in corrugated board and display for sale and exposure. But in more recent years, they started developing a lot of packaging solutions suited for direct food contact with packaging. With the food packaging. They use both recycled fiber and virgin fiber, and they started to get into also the use of bioplastic. EcoFood is the business unit that is specifically dedicated to food contact application. And all the eco-food packaging solution developed by this company are based on this material that is called HT board, which is a material made of virgin fibers obtained from certified forest. And the properties of this material, often in combination with some amount of bioplastic, guarantee hygiene and food safety also for direct contact application. And the general aim for the company is try to replace conventional plastic products presently in the market with this new material. What we did in the beginning, we already knew this company because actually we helped them in the certification of compostability of their products. So we had already some contact with them. Anyway, they apply for the pilot action within the BIOCOMPACK project. So we had some preliminary meeting to present our initiative within the project. We sent them the questionnaire, which is the audit tool you have already heard about in the general presentation. And we, as Innovab, we carried out one preliminary visit to discuss what the company reported within this questionnaire. Basically, what we did was to evaluate the framework condition of the company regarding the knowledge of the biomaterial, regarding their knowledge of environmental certification and sustainability. And we started discussing with them also what was their vision regarding their market strategy and how they wanted to communicate and advance in the field with their product. So based on this preliminary work that we have done here in Italy, we proceeded then with the second field visit that was done in cooperation also with the Packaging Institute from Poland. And during this second visit, we had a deeper discussion with more experts within the company. We discussed specifically regarding the strategy, what was their approach in this growing market about eco-sustainable packaging. And we basically found out that probably their weakest point was actually in environmental communication. So, in this context, we recommended as a priority action to perform a preliminary study regarding the life cycle assessment of their products in order to position the products with respect to this market. And we agree about this case study implementation that was in the end a comparison of their innovative paper-based packaging with plastic packaging already present in the market. And then we proceeded with the performance of this case study that was done in cooperation again with the Packaging Research Institute in Warsaw. In the beginning, it was a desk work from remote between ourselves and the Packaging Institute. Then we also had a 3 day of common work in Warsaw where we discussed deeply about the data provided by the companies, and we drafted a report. This report was then discussed with the company. We gave them some feedback, and we consolidated the results. And afterwards, we gave some final feedback to the company via a web meeting because we were already in the COVID time frame at that time. So this was the general approach to the company. I will leave then the floor to Greg to explain the details of the life cycle assessment, and I will get back for the final conclusion. Floor is yours.
Okay, thank you, Graziano. So yeah, Graziano explained that we did an LCA for the company. But before moving on to the actual results of the LCA, for those of you who are not familiar with the methodology, I just prepared like a free, very simple slides that should explain LCA better for you in like a simpler, more popular scientific terms. So life cycle assessment basically involves building a scientific model that shows a full or maybe a selected stages of life cycle of a certain object. This object can be a packaging, it can be a full product, it can be like a part of production of this product, or we can even do a life cycle assessment of a whole company or even whole economies if we have the data, of course. So what it involves? It involves modeling a sort of a biography and family tree of our product, as you can see in the middle of this model shown here. We do it by considering every step that needs to be taken for the product to live its life. So we look at all the processes that need to happen and all the different stages that are happening from the moment when the product is just raw materials until the time when the product actually becomes a waste. And yeah, to help us with this, so once we have this detailed biography and family tree of our product, so to say, so we know what happens, we then have to document the inputs and outputs of all of those products. So we are looking at what we have taken from the environment to achieve those certain stages, and also we are looking at what we are leaving behind in the form of emissions. Those can be emissions to the atmosphere, the emissions to soil, emissions to water, etc. We therefore build this like a very detailed inventory of different inputs and outputs, and they take form of specific materials that we use, compounds, or even chemical elements. And to actually help us with this very complex process, we use databases, those databases already include many of those inventory items for inputs and outputs for like a very specific like materials or even full products. For this assessment, we used a simplified LCA, and simplified LCA means that we are mainly using databases as our source material. Normally, when you do an LCA, you first base it on a database, but then you really need to do like a detailed measuring in the company to see exactly what happens where. But in order to do like a simplified LCA, just using database as like a main basis of your data is enough. So we did that for pilot action. Our LCA was done for packaging, and packaging is actually a very interesting subject matter for LCA. Because when we do an LCA of packaging, we can look and take into account like many very interesting aspects of packaging, such as, for example, multi-usability or recyclability, or the eco-design, or the infrastructure, or even the use phase of the packaging, and of course how the packaging is also disposed. Also, very importantly, life cycle assessment can be used as a comparative tool. So we can compare 2 or 3 different products together and see what are their environmental strengths and weaknesses, and which one is better or worse from the perspective of different environmental impacts. Again, packaging is like a very suitable subject matter for LCA. Because in order to use this this function of LCA that allows us to compare different products, we need to do it properly. And do it properly, those products that we're comparing together, they need to be comparable in relation to function. So packaging, again, here is very nice because for packaging, the function is the same, to pack products. So we can, for example, compare glass bottles to plastic bottles, or paper bags to plastic bags, or biocomposites to traditional composite packaging, which is something that we did precisely here. Once we have this model built out of this previous slide that I showed you, where we are building like this detailed biography of our product, we need to build building this model, and then we go to the next step of analysis, and that level of analysis is called the impact assessment. So we are taking into account the data from inputs and outputs that we collected, and then we use scientific basis and different scientific methods to assess what is the impact of the products that we assessed in this life cycle assessment on different environmental issues. And those environmental issues can be like, for example, global warming, energy utilization, water footprint, resources use, pollution, ecotoxicity, etc. We have like many different methods that allow us to look at different sets of environmental impacts. And of course, we do it for whole stages of the life cycle, as indicated in this graph. So for this specific pilot action, we used like a product from Big Packaging, which was a paper tray, and we actually compared it to two different products. Really, to be truthful, we compared 4 different packaging that has the same function, and that function was the packaging of 300 grams of fresh meat. For the system boundary, we look at the whole life cycle. So we look at from cradle to grave, and that simply means that we look at from the point of collecting the raw resources to produce this packaging, up to the point where this packaging becomes waste, and it's either recycled, incinerated, or whatever else happens with it at the end of its life. For the products, we've chosen one paper tray from Big Packaging, then another paper tray which was like laminated together with or coated with PLA. So 2 products from the company that we cooperated with, and then we also took 2 plastic examples. So we took PET tray and polystyrene tray, and for the end of life, we made the following assumptions. So we decided that the paper and PLA tray is recyclable, because there's like less than 5% of PLA in the paper PLA tray. This tray was considered to be recyclable, and correct me if I'm wrong, Graziano, you did some tests for recyclability of this.
Yes, we did. So it was tested also in lab, beside just looking at the percentage of PLA. So it was actually recyclable.
So yeah, so we decided that this paper PLA tray can be recyclable in this traditional material sense. For PET, we also considered recycling, because this is like a widely recycled material. But for polystyrene, we considered no recycling in here. And this is because while this material is in theory recyclable, and you can recycle polystyrene, in practice it doesn't really happen. It's not economically feasible to do so. Polystyrene is normally either incinerated or landfilled, like for example in Poland. Also, what is important, the paper trays were made from 100% virgin fibers, which were certified by FSC. So this is the setup, and right now for the results. So this is how the results of LCA look like. In here, let me just draw you, like in here, we have a set of different environmental impact. And in here we have 4 different products. So we have the paper tray in green, the paper PLA tray in blue, in orange we have the PET tray, and in yellow we have the polystyrene tray. And basically the relative height shows the environmental impact on the specific category. So we can straight away notice that the 2 major categories that we have here is agricultural land occupation and fossil fuel depletion. And we can see that in agricultural land occupation, the highest results are for the paper and paper PLA trays, which is very understandable because we have to grow our trees and grow our corn for PLA to be able to produce it. However, when we look at the fossil depletion graph, we can see that the categories here are reversed. And this is because, of course, for PET and polystyrene, we need to get the fossil resources. So the major impact for plastic trays is in the fossil depletion category. We can also simplify those graphs a little bit. So we do it by compressing different categories together, and there we can see more easily and understand a little bit easier where are the main impacts in those 3 categories, which is damage to human health, damage to ecosystems, and damage to resource availability. And we can see here that it basically confirms what we saw before, that we have like the major impact of paper and PLA is in ecosystems, and for the resources it's the plastics, and also for human health it's also the two biggest impact categories are here. But then we have this slide, and this slide actually compresses the previous slide even further. And in here we have those 4 slides, those 4 trays positioned side by side with like different damage categories of human health, ecosystems, and resources shown like that. And this is where we can actually see the comparison between those 4 different products. And this is very interesting. I'm guessing you can see straight away that this is very interesting. While it's obvious that the PET tray has got like the biggest environmental impact out of all those 4 trays, we see that the polystyrene and paper tray and paper and PLA tray have actually got a very comparable result, as you can see by this dashed line, red line here. And this is even when we actually didn't consider recycling for polystyrene, and recycling was considered for paper. Why is that, you can ask? And the answer is actually pretty simple. So polystyrene trays are produced from expanding process. It's called like the actual material is called expanded polystyrene, and this means that they are very light. We need much less material, much less polystyrene to produce a tray which has got like a similar functional unit to all the other tray. Then we need PET granulate or paper or PLA. So that means that the results are so low because this material is very light. But does it mean that polystyrene is therefore like the best solution? Like from the perspective of LCA, which is the environmental assessment of products, and based, of course, on our assumptions, maybe we can say yes. But there's more to this story, of course. And while looking at sustainability, we do not only assess environmental impacts and environmental issues. We need to look at economic issues and also at the social issues. So the results are extremely interesting, but this is not the whole story. And I'm guessing that Graziano has more on this.
Thank you, Greg, for showing the detailed results of the life cycle assessment. Yesterday was actually mentioned that there are not very many at least independent studies looking at LCA of biocomposite. We are aware of that, and this is actually one of the interesting results of this pilot action, because we started looking at the comparison between a biocomposite and some plastic products that are already in the market. And as Greg mentioned, the polystyrene is a very light material, and that's the main reason why it came out as being still slightly better in terms of environmental impact in comparison with paper. Nevertheless, the bigger problem with expanded polystyrene is that it does not guarantee the circularity of the system. And even in the best case, I have recently read that, for example, in United States, the percentage of polystyrene that is actually recycled is less than 1%. And I believe in Europe is pretty much the same. Very often when we compare life cycle assessment using a database, we use average plastic recycling, but that's not really the case when you look at a specific material, because there is a huge difference between polyethylene, polypropylene, even polyethylene terephthalate in comparison, for example, with the polystyrene. So I think it's important, to do a fair comparison, and this was a first attempt for us to compare a biocomposite with based on paper with the plastic that are in the market. Besides, of course, polystyrene risk of being totally prohibited as a consequence of single-use plastic. This is definitely true probably for polystyrene, whereas we still do hope that will not be true for biocomposite. And we hope to be able to show that some of the biocomposites, if they are properly designed, they can be recycled and in the paper stream, or occasionally also in composting plants. But it's not always the case that these products are devils, let's say, the multi-material. It really depends on the design. So getting to the point of this paper-based trail, we notice that the addition of PLA from one side increases functionality, and from the other side, it shows only a slight increase of environmental impact. And this is good, because it means that when we combine some material, we can actually achieve functionality and at the same time maintaining a correct end of life of the products. And therefore the circularity of the fiber loop when you recycle the products in the paper industry. I actually did not mention it specifically, but the same products, it is also compostable. So for this paper-based tray, we actually have two recycling options, and depending on the type of application, so if it's an application like the one that we showed in this presentation, with very greasy, food like fresh meat, this type of product could be recycled also in composting plants. Last but not least, this product is still a new product that can have the possibility to be further improved in comparison to other products that are in the market, that have been in the market for a very long year. So in the end, we think that paper PLA tray may have a good potential to replace some of these conventional plastic products on the market. But in order to also to proceed to make some step further, we gave some feedback to the company, some recommendation. And one of it is to perform a full LCA study, because as Greg mentioned, this was a sort of simplified study based only on the data that we could find in the database. But on the other hand, taking into account the fact that this company holds forest certification, if we look at the primary data, probably we will be able to show a reduction in the environmental impact. Besides, it's still possible to work looking at the reduction of the total weight of the products. Keep in mind that the paper products was much heavier than polystyrene, and even a smaller reduction would lead to a better environmental footprint. And this is possible. This is possible to looking at the different fiber stock, or also looking at the use of some reinforcement additives. Last but not least, again, it is probably possible to replace a part of the virgin fibers with the recycled fiber. This would definitely be the easiest way to reduce the environmental impact of the products. Nevertheless, at least in Italy, we have some legislation constraint on food packaging in direct contact with greasy and wet foodstuff. Recycled fiber are not allowed. This is not the same in different legislation, but in Italy we have a lot of constraint on this issue. But the company could also look at the possibility to use PLA as a barrier to some contaminants, and then find a way to implement at least a part of recycled fiber within the product. Okay, that was it. I hope we were clear enough about this LCA, which is not always easy to explain, but we are open to the question. And you could also, if you don't have a question now, you can contact me. You see here my email address. Thank you all.
Thank you very much, Graziano. So yeah, I open the floor to questions. If you have any questions, be sure to post them in the chat, and we will try to answer them as best as we can.
No question, Greg.
No questions, at least not yet. I'm still typing. So yeah, let's give them one.
Okay, we know that the matter is complicated and maybe takes some time to think about.
Once more, those presentations and case studies for the pilot actions as well, which will take form of a document, as I remember. So they will be in the form of like a nice and concise document. They will all be available later. Oh, we have a question, I think. Look at that. Yeah, the question from Professor Marek is: are we planning to publish those LCA results?
Well, we got the permission from the company to publish what we have shown in this presentation. I think these are the data that we could publish at the moment. But we are going to get back to the company and see how they react on potential paper.
Yeah, of course, like they will be published like internally, not really internally because you all have access to it, but you will be able to get those results through the Paper BioPack website, which I will tell you more about tomorrow. But when it comes to the actual publication in some kind of a research paper, I think it's a pretty good idea to do it like that. Okay, we have a question about which PLA grade was used in the project.
Yes, I don't have this information, at least not. We are not allowed to tell exactly about the material itself. The company just allow us to present the general composition of the material. So it's PLA, but I cannot disclose what kind of PLA it is.
So yeah, let's wait like a couple of seconds for, yeah. So Wojciech said, thank you. Great. Okay, if we do not have any more questions, then I would like to close for the day. We still have tomorrow, and tomorrow is also going to be interesting because tomorrow we'll be talking more about environmental issues, something we started here now. Graziano will also have like a very interesting presentation about, let me just quickly snap and look at what is the actual title. The title is End-of-Life Issues for Recyclability and Compostability within the Context of Circular Economy. We'll have a very fascinating keynote from Professor Marek Kowalczuk, and we'll have a presentation from me and Andrzej about the paper BIOPACK initiative, something called within the project the Transnational Biocomposite Packaging Center. And this is one of our main outputs of the product of this project, of BIOCOMPACK project, and something that you will be able to join and interact with us even after this project is finished. That was like the main idea. So we will discuss it tomorrow. We start tomorrow at 10 o'clock and should finish at around 1 o'clock. So thank you very much for your numerous participation today. I was like really positively surprised how many people we had yesterday and how many people we have today, and I hope that it will be the same tomorrow. See you tomorrow. Thank you very much, and have a good afternoon. Bye-bye.
Thank you all. Bye.